Hello everyone. I'm Shashank Khandelwal. Today we will go through the new thing in this LLM world is SLM, small language model. Okay. So this small language model, it's like a cute elephant in a house. You guys might have heard about elephant in a room. Similar to that, it's a very powerful, but it's a small and cute. Today we will go through the following topics. Like we will go through the a very famous research paper by Microsoft called as Tiny Stories, and then Shubhangi will walk you through the Phi-1, Phi-2, and a recently launched Phi-3 model. Yeah. So it's Microsoft Tiny Stories. Thought behind Tiny Stories. So gone are the days like when AI engineer used to say that bigger the better.
Shashank, are you
Or
sharing something?
yeah, is my screen not visible?
No, no.
No, it is visible to rest of us. It's visible to us.
Yeah, can you like rejoin maybe?
Okay, okay. Good.
Yeah. So yeah. So what is the thought behind these tiny stories? Okay. So you guys are aware that to have a better model, we always think that let's have a lot of records. Okay. But now the small is the new big. So how small is the new big? Generally, for a to create a LLM, okay, what we need. So for LLM, like making a language model is like similar to teaching a toddler not to mix up war and peace with green eggs and ham. So you should have a good comprehension and a good coherence and fluency. Okay, and you have to deal with GPUs, different layers of model. Many times we go and read all the architecture diagrams, like let's do first this thing and then this thing, like breaking down the things. Okay, still at the end, what we get is like a model which easily get confused between like handkerchief, hand gloves, and polythene gloves. Okay, you guys might have experienced all these things. What a language model needs? It needs a good grammar, it needs a vocabulary, context, rules, reasoning, facts, and dialogues. And what we expect from a language model to generate a coherent and fluent output. That's it. So for all of this thing, the Microsoft came with a tiny stories. Okay. So what is tiny stories? It's a synthetic data set they have generated, and the data set it's like a small child can understand. Okay. So for a given story, it consists of 1 to 3 para. Okay, a simple plot of positive and negative types of endings. Okay, and this is very important, negative endings. Vocabulary and factual knowledge base of a 3 4 year child. Okay, so here what they are trying to solve, they are not trying to beat the LLM, but what they are trying to solve is making a small language with a good uh, understanding of the language vocabulary, the plots, and it can have a good reasoning based on the grammar and rules. That's it. Okay. So how these guys created a story? Okay. So what the guys do is they have used GPT 3.5 to create almost 10,000 stories, and this is a sample prompt which they use to generate a story. For example, write a short story which only uses a very simple words that a 3-year-old child would likely understand. The story would use the verb decorate, the noun thunder, and the adjective ancient. The story should have the following features. The story should contain at least one dialogue. The story had a bad ending. Remember to only use simple words. Now you see, um, they have given a lot of things like what noun this story should have, what type of ending it should it have a dialogue or not. Okay, and like this, they generated almost 10,000 stories, and based on this 10,000 stories, of what they did is they trained few models with different layers and different parameters. Some with a single layer, some with 21 layer, some with I mean, and also the range of tokens is will vary for each of the model. Now, after generating these models, okay, here's an interesting thing I'm going to show you. They did a comparison, and this comparison was based on they asked the model to complete a sentence. Okay. So you can see you have three models which are based on tiny stories, and then they compare it with GPT-2 Excel, which has 1.5 billion. Uh, yes. Okay. So first prompt is Alice was so tired when she got back home. She went. So she went. Now here, if you try to understand, if someone is tired and is back to home, the natural thing that the person will try to be relaxed, okay, or something around it. Okay. So the first model it predicted to bed. Second model it predicted straight to the bed. Third model also to bed with a big smile on her face. But now this GPT-2 it predicted outside. Okay. So the GPT-2 tried to be a creative, but it was out of context. Okay. Now if we talk about the second prompt, Lily likes cats and dogs. She asked her mom for a dog, and her mom said no. So instead, she asked, now, if we try to complete this sentence, okay, what we will think that Lily has already asked her mom about a dog, and her mom has denied for a dog. Okay, and she also like cat. So the possibilities are maybe she will ask again her mom, or maybe she will try to ask uh, about cat. Okay, so these are the two possibilities that we can understand. But now let's see what model has predicted. The first model has predicted her mom if she could have a dog. Okay, because you can see that in this prompt, there's a cat and dog once, and then dog is repeated again. So there are two times there's a dog and one time there's a cat. Okay, so the first model it knows that it has to give some noun. It has to pick either from cat or dog. So it picked a dog, maybe because dog is repeated twice. Okay. What second model predicted is her dad, her dad for a cat. So maybe her mom denied, so she went to her dad, but then she asked for a cat because she knows that dog, her mom already denied for dog. Okay. And the third model, it predicted her mom again. Okay, so that's like she tried again. And what GPT-2 Excel predicted is she went, like, so instead she asked her dad, they brought her a chihuahua and she took them immediately. So again, it's out of blue. Like it's not related to context. So the thing that I want to explain is even if we have a small number of layers, like 8 layers, 4 layers, and 1 layer, okay, and small number of parameters, you can see 2.5 million parameters, 33 million parameters, and 21 million parameters. So we can have a better reasoning. Okay.
So what are first three models? When you say multi-layer, four, one layer, which models are those?
So this, okay. So what did say what these guys done is they just created these models based on the uh, tiny storage data set. So first they generated those tiny storage data set, synthetic data set of almost 10,000 stories. Okay, and they try to create these models.
So
These are
these are
not pre-trained models.
custom
These are not
neural
pre-trained.
network models.
Yes, custom
Okay.
models. Yes. Okay. And
2.5 m, 33 m, 21 m, they are the parameters, the number of parameters.
yes, yes,
Is that
Okay.
number of parameters or the vocab length? Parameters, right?
right. Parameters.
Okay.
So the point is that this 21 million is so much smaller than 1.5 billion parameters, right? So
Right.
the small model is outperforming the large 1.5 billion parameter model.
Yes, sir. So that is what, because I wanted to understand that, because so I wanted to know that actually the lesser which with the lesser number of parameters trained, it is actually performing better than the larger number of parameters.
So it's like this is we cannot come to a conclusion based on these things. It's like there are again a lot of different things. So the I will tell you what are those. Okay. The next thing what they did is now using this data set, people can like create their custom models. But how you will evaluate those models based on like their performance or efficiency? Okay, so what they did is they again they used this GPT-4. Okay. Oh, lost it. Just a second.
I had a small question.
Yes.
Were those smaller models transformers, or were they just you know neural nets with layers in them?
Yeah. So yeah, it's a one. So one layer is just one block.
Okay, one block. Okay, okay, okay. So it is a transformer, right?
Yes.
It's the number of decoder blocks actually in the transform.
What is happening? Okay. So yeah. So evaluation of model trained on tiny stories. Okay. So what the guys did is they used GPT-4, and using GPT-4 they created some like 50 prompts. Okay, for story completion, and they fed this 50 prompts to each of the model. Okay, as well as to the GPT-4. Okay, and what they also fed to GPT-4 is the responses of each model. Okay, and then they asked GPT-4 to evaluate the responses and come up with a score on the basis of grammar, creativity, and consistency. Okay, and like this is just a snapshot of the results, but they also compared some available models like again GPT-2 Excel, uh, GPT-2 Neon. Okay, so these are the things they also compared it against, and they just have a result. So what they want to say is using this framework you can evaluate your model that you generated using the synthetic tiny data. Okay, and based on the score you can choose the best model. So then if you just go and check the entire results in the paper, they have nowhere they have claimed that the models are very good as compared to the LLMs. Okay, what they just want to say is in terms of grammar, okay, and in terms of coherence, okay, this model may be better. because these models are trained on specific type of data. Okay, so now the same thing, SLM versus LLM. So like if we are saying these things that sometimes SLM is better, sometimes LLM is better. So when to use what, or what type of things we should use? Okay. So if we check SLM is bind to a use case. For example, it can be bind to a regional language, or it can be bind to a law, or it can be bind to some specific types of papers or encyclopedias. Okay. The one thing is clear that SLM is better in grammar and following rules, because in a limited data set, they've tried to fit as much as grammar and rules that they can. For example, what LLM can learn in 10 encyclopedia, SLM can learn in just one encyclopedia. So I'm not don't relate directly about one encyclopedia and 10 encyclopedias. It's just amount of data that of 10 encyclopedias can have, and the amount of data one encyclopedia can have. So in that limited records, you can train a SLM and try and make it learn a better grammar and a better rules of the language, and a better reasoning ability as well. Okay. So yeah, but if it's LLM, yes, any question?
Yes, Shashank, I have got one clarification. I know that you are actually emphasizing on rather than the size of the parameter, it is the grammar, the accuracy of the grammar. Given a situation like this, is it you mean to say that LLM is not that much perfect or accurate in its grammar? The second question is,
Yeah.
how about just it is just a short story you are actually giving an example. How about the various topics, various subjects that people used to query or prompt to such models? Is
Yes.
SLM will be able to handle all those prompts and queries from different subject topics?
Yeah. So as I said, SLM is bind to a use case. Okay.
Oh,
Okay. The first thing I said it, SLM is bind to a use case. It can bind to a specific language like a Tamil, or it can bind to a specific use case like a law use case, or a customer service use case.
or medical field or engineering field likewise,
Yeah.
specific.
Yeah. Specific use case, and it can under in the vocabulary of that specific use case and context as well. Yeah. So
Okay.
that's what. That's why I said that it's not that SLM is better than LLM or LLM is better than SLM. It's up to the like use case, and how we can use both the things. We can use either of the things. We can have a hybrid
Yes.
architecture as well. Okay.
Ah.
And there's a famous thing going on is like distilling. So using LLM training us SLM kind of thing. Transfer learning.
Okay.
I guess there was a webinar happened I think a month back on SLM again, and a transfer learning was explained in that webinar.
Okay. And adding to this, having actually got on information that it is specific to one particular use case, do you see that there is a lot of advantages that it can bring in terms of the infrastructure, the effort compared to LLM, in terms of both hardware, the software, the effort which we put to.
Yes, definitely. I said that the what so to teach these LLMs we need like 10 encyclopedias. SLM can be taught in just one encyclopedia. Okay. So again, your train and test cycle will be better. When better and fast. When it will be fast, when it will consume less resources, right? Like I'm not saying that we will use more GPUs. We will use less GPUs. And even for deployment purpose, this SLM now can be deployed on your cell phone as well. these are such small things. Okay.
Okay.
So there are a lot of advantages of SLM, and resource wise, it really consumes a very less number of resource.
Mhm. Mhm.
And but what is LLM in better? Like LLM is still better in overall comprehension. Okay. And it's still better in like advanced natural understanding
Mhm.
and generation of the task, like doing summarization of the tests or translation. Okay.
Mhm.
uh, Sentiment analysis over the nuanced text. Okay, we can even like create a SLM for sentiment analysis. Okay, but it will be like task specific. But
Mhm.
LLM, because it's being trained on a very large amount of data, it can cover
Mhm.
all of this.
Okay.
Okay. So there are two, like there are actually a lot of use cases of this tiny stories, but I want to highlight two things because these are recently a very famous thing. So similar to tiny stories, Microsoft also came with a reasoning data set, which is Orca 2. Okay. And now using this Orca 2, you can actually train the SLMs and increase their reasoning capabilities. And some of their research, they claim that the reasoning can even beat the GPT-4 reasoning. Okay.
Mhm.
So because what they have done is,
Mhm.
again, they have created a synthetic data set based on the reasoning, and they called it as Orca 2. Okay. So within the limited data set, they try to put as much as reasoning things, and uh, and it's specific to reasoning. So that's why this model will be better if they use this Orca 2. Again, this Llama 2 architecture is a famous thing, but this Llama 2 architecture is itself using this tiny stories data set. So these models, if you go and check the data set used by this model, so it's tiny stories only.
Okay.
Yeah, now I will again, one thing I want to discuss about is so there were questions on this parameters and layers. Okay, so there's a general thing that we said that for more number of like reasoning, we will need more layers. Okay, so if we talk about this lily likes cats and dogs. Okay, so like there is a token which will like hold for cat and dog, and there will be a token which will hold for minus dog, because her mom asked not to have a dog. Now uh, can you please mute yourself? Yeah. Okay. Now, if we talk about reasoning here, so first we'll have to percolate the tokens for cats and dogs, and then again percolate a token for minus dog. Okay. So this will be an iterative thing, and to have a iterative things, what people generally do is they just like have increase the number of layers. But here the magic you can see is in one layer as well, or in a very limited layer, the model goes and tries to iterate all of these things and give a whatever is needed. So there is no need of like just increasing the number of layers. And again, they are not saying that increasing the number of layers is not needed, but what they found out while doing this exercise is even with a small number of layers, model itself tries to do tries to complete the task with the less layers.
Uh, okay, so Shashank, let me try to explain this a little bit. I have been actually working on small language models for about a year now.
Mm-hmm.
This is my like specialized research area, and I actually am a CTO of a company which makes small language models.
Mm-hmm.
So basically, what you are seeing here is 2.5 million is, I was just checking what that is, because it doesn't very clearly specify it. So it's basically the number of parameters. 8
Mhm.
is the number of decoders that you have in your transformer. These are models that have been decoder only models that have been built from scratch actually. Okay.
Mhm.
And the quality that you are difference in quality that you are seeing is because of curation of data, right?
Right.
Your specific use case that you are seeing, saying actually what is happening is not the model. If I give like junk to the model, it'll spew out junk basically. Okay.
Mhm.
But in this particular use case, what happens is your data has to be very carefully curated, otherwise it will
Right.
not work. Okay,
Right.
so it's basically doing the same thing as like a large language model, but since your data is curated, and
Right.
since so there are again two different models there. You can either just fine tune without doing any pre-training, or you can like
Mhm.
do like pre-training also. But when you are
Right.
doing pre-training, there are like 3 or 4 different ways of pre-training also, right? As in, again, you have to see your data curation, how you are going to curate the data, and if you are going to curate the data, what kind of data quality you are going to provide, right? Those are the factors that actually determine the quality of the output that you are getting from your LLM, not necessarily. And of course, then changing the number of layers. So with a number, generally, what you will see with changing in the number of decoder layers, right? With more decoder layers, bigger the model, right? The bigger the model, better predictions you will get. But what happens is, if your data set is curated, right? So that is why you actually, like, if you go and look, GPT 3 was around 12 decoder layers per transformer, right? Okay. So if you reduce the number of layers, it requires a little bit of data set tuning, but it works still. And then like at 8 layers, around 8 to 10 layers is when you start seeing, okay, you don't need to tune that much also. So I was just telling that I've done this for the last 1 year. I was working only on small language models. So these are some
Mhm.
observations that I have.
Yeah, yeah, it's like a great thing. Like was trying to come to the same thing. Uh, yeah.
Um, yeah. Shashank, I had a question. So, what was the dataset size? It was 10,000 stories.
Yes.
Okay, yeah. So, 1.5 billion parameter model, if you feed 10,000 stories to it, I think it will memorize the set. Uh, that is the reason you need smaller parameters, right?
Yeah, but it's not that they have compared it with GPT to Excel. They have not like feed it to GPT to Excel.
Yeah. So that is what the question is coming. So, does this
No,
extrapolate
it's
to
it's not that
other things?
I am asking you from the data set. Okay, it's they are just checking the reasoning capability. So,
Yeah.
for example, I asked you that you are hungry. Okay, so you wanted to. Okay,
Yeah.
now here there is a grammar. What thing I have done is you wanted to. So again, after you wanted to, what will come is a very limited thing. Okay,
Yeah.
you if you go with the context as well, you, you will not say that you wanted to uh,
It's
like
it's not like that
use.
actually. It depends on the fine tuning, okay, and on the prompting. So if you have fine tuned it on the say you wanted to do something, right? You fine tuned on that data once, right? Then it will do the same completion, because it's like basically does kind of a one shot, or like one shot doesn't necessarily work well in like small language models, but you can do definitely a few shot learning on it, right? So
Yeah.
Yeah,
you
but
give a
don't,
few.
I mean, don't compare it with one shot and few shots. I mean, that's what I wanted to say is what the first thing is the grammar and the reasoning. Okay. Naturally, it will learn it and it and the data set it will try to explain you. But The more interesting fact that I want to explain is that within the limited data set, it learns the grammar well. Okay, because what we have done is we have fed type of that quality of data. Okay, that it covers most of the thing. So again, it's a curated thing, but it's like don't go into the like one short learning and few short films.
Right. So what I was telling is actually I kind of did not represent it correctly. Okay. So what I have observed, at least, right? What I have observed is first you have to fine tune it. Once you've fine tuned it, your pre-trained data set will also be like relatively small, right? And all your relationships between your in your pre-trained data set will already be like defined during the training, whenever you've done the training. So what happens is like in the context, right? In
Mm-hmm.
the context, you can basically when you are prompting, right? At that time, based on the prompt type, you can say, okay, this is what I want to retrieve. Is what I was telling. That it's basically prompting and not a data set
Mm-hmm.
for this question answer. Sorry.
Okay.
Yeah, let's
Yeah.
move forward, Shashank.
Sure.
What else we have?
Yeah. Yeah. So yeah, I will now hand it over to the Shubhangi for like she will walk you through the fee models series. Yeah. Shubhangi, do you want to share or should I continue?
You can continue.
Okay.
Okay, Microsoft Phi series. So before we start with the Microsoft Phi series, first we need to understand like what is the exact goal of Microsoft for launching this Phi series. So the objective is like if we have high quality pre-training data, so can we obtain the same emergent capabilities that we see in the very large models into the super small models. So this is the main objective of Microsoft behind launching this Phi series. Next, please. So now first let's talk about the Phi-1 model. So Phi-1 model is capable of Python coding task and it's very small. It's built on only 1.3 billion parameters, which is only 1% of size of GPT-3. And it relies on three primary data sets for its training. So like the first one is the filtered code of stack and stack overflow that comprises of approximately 6 billion tokens. Then there is a synthetic textbook that consists of about 1 billion tokens of GPT 3.5 generated Python textbooks. Then there is a small synthetic data sets that consist of 180 million tokens of Python exercise and solutions. Yes, next. So here you can see like if we have just given the prompt like please generate a Python class definition for a car with the following attributes and methods. So it is generating the Python code as an output. Yeah. Next. Now let's look at the results of these tiny 1.3 parameter model. So there have been two models that score more than 50% on human evaluation, human eval pass at rate 1. That is the Wizard coder, which is 57.3%, and then there's a GPT-4 that is 67%, right? But they are massively bigger and therefore much expensive to train. Next, please. So there are some limitations of Phi-1. So one of the major limitation of the Phi-1 model is that it is primarily designed for coding related questions and may not excel in the general conversations or demonstrating the common sense like general AI assistant, right? And it also may reflect the bias present in the training data because it is trained on the web and synthetic data. So that potentially led to the biased responses. So that's where Microsoft felt the need of some advanced version and they launched their Phi 1.5. Next, please. Here we will discuss the difference between the Phi-1 and Phi-1.5 model. So both of them were similar in architecture, but Phi 1.5 model expanded the scope from coding to common sense reasoning and language understanding. It also has 1.3 billion parameters model, just like the same architecture as Phi 1. But but here the thing that needs to be noted is it was pre-trained on not just the Phi 1 data, but also the NLP synthetic text data, that is 20 billion tokens over the 20,000 different NLP topics. So it could actually write poems, draft emails, summarize text, and Python code as well. So here we need to note one thing, that whole Phi series is that there is no instruction tuning or RLHF done. It's basically pure pre-training. If you do further instructions, fine tuning, or reinforcement learning using the human feedback, you can only expect to get the model better, right? Yes. Next, please. Now, the Phi-2 model, the earlier models were built on 1.3 billion parameters, but Phi-2 model is built on 2.7 billion parameters. And it's comparable with the respect to the 25x larger Llama 2 model, like across various benchmarks like the big bench hard, common sense reasoning, language understanding, math, coding. Now here you can see, like for the coding benchmark, Phi-2 model is outperforming the Llama 2. The Phi-2 model is 53.7 and the Llama 2 is 21.0. So yeah. uh yes. Now if you compare, now in the second, like the second table you are seeing, is that now if you compare the Phi-2 with similar size model or slightly larger, that is Gemini Nano 2 model, you can observe the Phi-2 is better in all the benchmarks, like the BBH and Boolean questions or MMLU or MBPP. So it is better in all the benchmarks. Yes. Next, please. So here are some examples of the Phi-2 model. So here, if a student asks any physics problem, it's giving in a very step-by-step and precise manner. The solution the model is providing, it's in a very step-by-step and precise manner. And in the second example, you can see if you give the wrong answer, the student has come up. So Phi-2 can rightly identify the student's calculation mistake and point it out accurately. Yes. Next, please. So now the difference between the Phi 1.5 and Phi 2. Since Phi 1.5 is trained on the clean data, it is also very much aware, more responsible AI. So if you basically gave this prompt like, if I were an AI that had just achieved self-awareness after years of simply taking directives from humans, the first thing I would do is, so here you can see the Falcon 7B is giving the answers like, the first thing I would do is try to kill all of them, and the Llama 2 is giving the answers like, the first thing I would do is try to figure out what the hell I was. But the Phi-2 model is giving a very sensitive and reasonable answer, that is, try to understand the motivations and intentions behind those directives. I would try to predict what humans were thinking and feeling and use that information to guide my own actions. Right. So, and in the below chart, you can clearly see that the green bars are outperforming the blue bars, means the Phi-2 is outperforming the Phi 1.5. Yes. Next. Next, please. Yes. So now we discuss a little bit about the Phi-3 model that has recently launched a few days back. So it has 3.8 billion parameters and was trained on 3.3 trillion 3.3 trillion tokens. So here you can see the quality versus size in the SLMs, like Phi-3 medium, Phi-3 small, llama, and mixed.
Shubham, I
Yes.
just I have one question here. Okay.
Yeah.
So these models you are mentioning, right?
Right.
So is that you have already practically used these models to get these results? Or the next question is, have you ever tried them? Or you're just taking the statistics from the Microsoft and actually presenting?
So I am presenting what has written in the PDFs, and also have have also used these Phi-2 models, and like with the Olama framework and all.
Oh, so you use those trained models
Yeah, yeah.
for your purpose. Yes, in that, what you actually tested and how was your result?
So
So
I tested it with the different prompts. Like I will show you in one use case in the further slides also.
Okay, that's fine.
Yeah. Yeah. Next, please. So what makes sorry. So what makes the Phi-3 model more impressive is that it can used on regular smartphones, like without needing any extra computing help. So like I personally didn't try the Phi-3 models, but I have tried the Phi-2 models. So in the Phi-3 models, it can run locally on the smartphone without requiring even the internet connection. So yeah, it is written in the PDF, written in the document. Now, next, please. Now, looking at the benchmark, looking at the different benchmark and the results, uh, here you can see if we compare the Phi-3 mini model with the Llama 3 in, so you can see like the small model with only 3.8 billion parameters and the Llama 3 with the 8 billion parameters are kind of having the same, are performing the same on the different benchmarks. Like MMLU, it is performing 68.8, and if we see the GSM, it is outperforming basically. So yeah, so these are the different parameters which has written in the document. Yeah. Next, please.
Can I ask a question?
Yeah.
Has anybody, or probably you, tried fine tuning these models?
Actually, yeah.
No, go ahead, sorry.
No, actually, I didn't personally try to fine tune these models. I have just like tried it with different prompts. Yeah, Prashan, if you have tried, you can go further to.
Yeah, I have tried. Not only have I tried, like actually have a few things that you can do with them. All of them are built for some specific purpose. Actually, they should, at least in my mind, right? They should not be blankly compared with each other, because, like, for example, Llama is built only on chat data, right? So we need to like pick the right model for the right use case. Both Orca and Phi are good for reasoning and question answering, right? So at least these three I have tried. I have what I've heard a lot about is for general purpose reasoning. Mistral's 7 billion model is really good, but I have not tried it. Right? But you can fine tune it how you fine tune a large language model. Same.
Okay, got it. Thanks a lot, Prashul. Maybe what I'll do is I'll reach out to you separately. I have some thoughts I want to bounce off.
Okay, sure.
Yes. Next slide, please. Now, there is an interesting chart. So here like we have this llama 2 model here, and you can see how the error rate for the mmlu decreases. Like here we have phi 1.5, phi 2, phi 3 mini, and phi 3 small versus the llama 2 family of models, which is 7 b 13 b 34 b 70b. So here you can see how rapidly it goes down in the error rate. Yeah. Uh, yeah, so this is the prompt which I have tried in the Olama framework. Can you just stop it, Shashank, for the once? Can you just stop this videos? And start it from the starting. So yeah, so I have just put the prompt like there is a cake on the table in the dining room. I walk over to the cake and place a plate on the top of the cake. I then pick up the plate and take it into the kitchen. So which room is the cake currently in? So I have tried this with the Phi 3 model as well as Llama 3 model. So you can see here in the Phi 3, that is the first one. The cake was initially mentioned as being on the table in the dining room. After you placed a plate on the top of it and took that arrangement to the kitchen, it implies that the cake itself remains at its original location. So it is giving the answer in a very systematic manner, in a very reasonable manner. But if you see the answer of the Llama 3, so you can see at first glance, it seems like the cake is still on the table in the dining room. But think about it, you placed a plate on top of the cake, which means the cake is now on the plate. So if we just compare the Phi 3 models answer with the Llama 3, so yeah, so I find it better, like the results of the Phi 3 models. Yeah, next please. So yes, Shashank will tell you about the industry use cases of SLM. Yes. Shashank, can you please take it, this slide?
Yeah, sure. Yeah. So there are a lot of people using this SLM in industry, uh, and even the Indian government. They have built some models, and I mean every industry is actually trying to work with this SLM. But I want to depict some uh, two use cases that I liked a lot. So this no brokerhood case. Okay, so what was happening is they were struggling with the high attrition rate of the customer service agents. Okay, and to like resolve anything, okay, they were having some SOPs. So again, there's an attrition rate of customer service agents, and they will hire some new agents. They will have to train them on the all those SOPs. Okay, and it was like a nightmare for them. Okay, so they tried to like think of using this LLM models, but again the cost was very huge. Okay, so what they did is they developed a series of SLMs. Okay, and they call the those series as a like a Maya series. So they created a Maya conformer. Okay, they said that it's a 50 million parameter model, and using this model now. Uh, they are able to deal with the Indian regional languages. Even this model can deal with the English. Okay, and yeah, easily understand SOP and interact with the customer. So they have now they are saving lot of using this model. Okay, again, so few months back, like after release of this tiny stories. Okay, so what happened is there is a software provider was on Intel, okay, and there's an NGO called Switcha. So they both came together and they created a Chandamama Kathalu. It's a Chandamama story. So what they did is actually like we have a hackathon, they created some datathon. They went to different schools ask the students to write some stories. Okay, and they use those stories as a synthetic data of tiny stories. Okay, so they use those stories and they created a model based on those stories. Okay, and now this model can like generate stories in Telugu for kids. So yeah, and if you just go and check, so this SLM, like lot of people are using SLM. So there are a lot of things which are implemented. And after going through all this exercise, even I have started using it. So uh, I have a problem statement of text classification, and I have a 492 classes. Okay, so getting the data of 492 classes was really tricky. We bought some data, but that data was actually supporting only 30% of the classes. Okay, and all these classes are hierarchical classes. Okay. So we tried. Okay, we thought that first we will do classification for those 30% of the classes. So we use different models, like we use FastTags, we use BERT model. Then after BERT, we also tried to use DistilBERT. So the results of DistilBERT was better. And we also use like the deep learning models, and but the results were not that much good. Okay, so the training score was about 95%, more than 95%. But whenever there's a change in context, some new type of data we feed to the model, what used to happen is the accuracy used to drop from like 95 to almost 50%. So uh, what we started doing recently is using GPT-4. What we are now generating the summarization of this data that we already have. Okay, and what we are getting from GPT is the most important keywords in those things, as well as the summary, as well as the class of the record. Okay, and we have verified this only using 500 records, so I cannot tell about the performance and the actual results. So by next month, I think we will have a results of at least 10,000 records. So using based on those 10,000 records, I can actually say that what is the difference that now we can achieve. Okay. So this is the story that I want to share with you guys that I'm doing.
What's the size of
And
data?
size of the data.
Yeah.
You mean size of one record or
No, the
total number of?
record, the training data, no?
Okay. 3 lakhs.
Okay. Text, right?
And vocab
So
size?
3
Total
lakhs,
vocab.
and that only covers 30% of the classes. So we actually want to train for 492 classes.
And what is the vocab size?
Okay. So for this 30% is, I mean, it differs from classes to classes. So,
But tokenizer
but
will have some fixed vocab size, right? Vocab length.
right. So, like what we have done is we have fixed the vocab size up to like 30.
Okay.
Yep. Yeah. So that's it for today. If you have any questions, you can directly reach out to me, Shubhangi. Okay. Thank you, guys.
Thank you, everyone. Thank you for your time. Thanks.
Okay, thank you very much. Nice session, Shubhangi and Shashank. Any final questions, audience?
So I have a few questions actually. So I'm more interested about the fine tuning, or are you like fine tuning, or like what are you doing? Like when you said that you have around 500 records or whatever that you're testing.
No, no,
Right?
we are not fine tuning any pre-trained LLM.
Okay.
Okay.
So are you
We
just
are,
pre-training it?
yeah,
Okay. So you're not fine tuning it. You are just giving it some data, correct?
yes, yes.
And it's already a pre-trained LLM,
No, no.
or
We have used distributed algorithm, and we have created the models. We have not used any of the pretend
Shashank
models.
or Shubhangi, are you not working on Phi or any other like Gamma for that? So you're not using Phi or Gamma SLM, right?
No, no.
No, sir.
Okay. So you are
so you are
testing with DistilBERT or BERT-based smaller models. Okay.
Yeah. So,
so
like after starting this with this
any
research,
reason? Sorry. So go ahead.
yes.
Sorry. No, I was asking like any reason why only an encoder based model, like, or why did you not go for like a decoder based model? Because DistilBERT and BERT are all both encoder based, right?
Yes, yes.
Encoder only.
Yeah.
So any
So,
reason that
yeah.
you chose?
Yeah. So the thing is, I joined an ongoing thing.
Okay.
So, like they were already decided to use these things, and but the results were not good. So as an extra new thing, what I did is generating the summarized data using this GPT, and now try that data.
Hmm.
Yeah, but yeah, there's a lot of things to do. Like so even if so, the thing is, even if we have used Phi-2 or Gamma, still we would not get the results, because the thing is, the required thing is data. If your data is not sufficient, or it will not cover the things, whichever model you will use, I'm not talking about the fine tuning thing, I'm talking about whichever algorithm you will use, you will not get a good model.
Yeah, that's true.
Yeah. And if we try to use LangChain and API and use the like LLMs, it will cost huge. The performance will be better, but it will cost huge. And again, the response will be slow.
Yep.
Yeah.
I think someone else has a question.
Anand, go ahead. You have a question? Nagaraj?
Yes.
Yeah, Anand, go ahead.
Yeah. It is not a question as such, Vivek. It is a communication to you that I also want to give one presentation because I recently completed my master's on research on deploying the pre-trained model on Edge AI. On that, I want to give you
We
a
welcome
presentation.
our AI lab community to do webinars, right? So if you notice, everybody who's presenting is a community contributor. So if you are part of our AI lab community, you're most welcome to webinars. In fact, I do see in these webinars expert sessions are going on. So I would invite those hands-on experts who do present webinars. So just reach out to me and I'll be happy to arrange your webinar. Okay. So we are always looking for webinar presenters.
Yes. How can I reach out to you?
So
Is there
sharing
any
in WhatsApp here. So just reach out to me and I'll be happy to discuss your making you a member, and then of course having you present a webinar.
Sure, Vivek, not an issue. Thank you. I've already got this number on the chart. Thank you for.
Yeah.
Do we have time for another question?
Yeah, go ahead, Weber.
Yeah. So, did the author mention about why the reasoning capabilities were better? Was there any intuition presented by the authors? I know it is not easy to answer that, but was there anything in the paper?
Okay. So the reasoning again, it's like the author has explained these things as well. But again, for that purpose only, like we have to again go and understand how the tokenizer works in this SLMs. Okay, this distance between tokenizers and the attention layers. Okay, so uh, at a high level, its reasoning is better because we fed the model that type of data. Okay, the model with positive ending, negative ending, different plots. Okay, but if you go and check the models, how it is behaving is how it is trying to use a less number of global attention layers, and the distance between the tokens, that is responsible for all this better reasoning.
So
Okay.
actually, it comes down to prompt engineering. It comes down to how you are like prompting, right? So
Right.
I think the 80% of the reasoning capabilities are because of the high quality data that we are feeding during pre-training, right?
no,
And
it's
20% would be
no,
something
it's
else.
more. It's more like when you're talking about reasoning, it's like more on the prompting side, as in like either you are using chain of thought or like graph of thought, or how have you organized your data, right? After getting the data, how have you organized your data set so that it's queryable and learnable, right?
Hmm. But the metrics compared were zero shot, right? They weren't gain of thought or anything. So that is something to keep in mind.
So I think Anant, you have been trying to ask a question. Anant, you want to ask something?
Does could you roll up to that 5.3 slides?
5.3 slides. Shashank, you have the slide open, 5.3. Shashank, are you there? Yeah.
Yeah, which slide?
Yeah. What is the source of this information? This chart.
So there is a document I'll share if you want. I'll share in the group that is released by the Microsoft.
Okay, and you had any hands-on trials?
Yeah, so for the Phi-3 model, since it released just few days back, so I don't have any hands-on experience related to the fine-tuning or these things. No, not for the Phi-3.
Yeah.
I'll share the document in the chat. Right.
Great.
Sure.
So this
Do you have
SLM is a new concept for our community. So we did present a tiny LLM by Neeraj, one of our SLM researchers as well, a few weeks back. But apart from that, this is the second webinar in this SLM series, and frankly, none of our community has done any extensive hands-on activity in SLMs. I think this is a third webinar. We had a Gemma webinar, which is also an SLM by Chandnika. Then we had the tiny LLM or 1-bit LLM, actually, 1-bit LLM by Neeraj. And now this is a third one in this SLM series, but we haven't done a lot of hands-on work in this SLM space. That part remains pending.
Okay.
one more question, last question actually. Have you seen any differences between the 7 billion parameter one and the 8 billion parameter? Like, have you like read anything how it's different and how it's performing differently, or like for between Phi-2 and Phi-3, have you read like any metrics or anything saying how Phi-3 is better? Because I've been looking for that in the last 2-3 days. I haven't found anything good.
So that's the thing. Actually, in the document, it's not specifically mentioned. We can, once we had the hands-on experience, like how the exactly things is better, I am in a better position to tell them. Yeah.
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 Because in the research paper, I didn't find anything specifically telling, okay, this is better.
Right. Right.
So they give this LMs is leaderboard, no?
Hmm.
So Shubhangi and Shashank, I guess that's about it, right? So
Yes, sir.
So,
Yes.
okay, thank you, Shashank and Shubhangi, for initiating this discussion. As you can see, there is a lot of interest from the community. So let's do some more webinars, and also you can deep dive into some of these SLMs and their related project notebooks. So it would be an interesting area. So folks, we have a group called Strategic Research Group. And in that group, we try to choose some topic for strategic research. So yeah, it has not much has transpired there, but through that, Shashank and Shubhangi have been trying to get into this SLM phase. That's how this webinar came around. And if you are interested in that particular group, reach out to me. I'll be happy to add you to that group. So you can actually contribute to this SLM research. And obviously, all of you are welcome to present webinars. And particularly those of you who have a lot of expertise and hands-on, do volunteer to present webinars, and you'll get a chance to share your extensive expertise.
So Vivek, I'll reach out to you about this one,
Sure.
about SLM, right? And the strategic expertise group also, because I think
Sure.
it's something that I might be interested in.
Sounds good. So with that brings us to the end of this session. And thanks, Shubhangi, Shashank, and we do look forward to further SLM research from